So, ladies and gentlemen, the last type of equation we're going to talk about solving is what's called the multiple angle type. So a multiple angle type is going to be very obvious to see when it's going to appear. Last night for homework, you actually saw some that you did have a multiple angle, but because you had double angle formulas, you did not have to go through the process of what we did today. How you're going to know you have a multiple angle type, for example, you're going to see a coefficient in front of your variable theta. So when you have a number in front of your theta that is not equal to 1, that's how you need to be on the lookout for your multiple angle type. So mainly, besides the double angle problems you had last night for homework, if the coefficient of theta is between 0 and 1, which when you did the double angle formula substitution, you were able to get just theta. So for example, sine of 2 theta is equal to 2 sine theta cosine theta. That formula eliminated that coefficient in front of theta. However, so there will be no answers than an equation with theta. We're going to talk about what I mean by that in a minute. If the coefficient of theta is greater than 1, then what we're going to have to do is we're going to have to do what's called a generalization. There will be multiple answers that we will have to find using that generalization. Remind me again, what was the period? This is going to go back to probably Unit 2, we did graphing. When we graphed our parent functions sine and cosine, what was the period for sine and cosine? 2 pi. So that's where this generalization comes from, for sine, cosine, secant, and cosecant. We're going to use a generalization theta plus or minus 2 pi k, where k is an integer. What is an integer? Can it be a fraction? No. So you're looking at 1, 2, 3, 4, 5, etc. So again, we'll need the generalization for all angles between 0 and 2 pi. We're still just looking for our solutions between 0 and 2 pi. The issue we run into is because of that coefficient in front of theta, it's not going to be straightforward just looking at the unit circle and finding all the solutions, because there's a calculation that's happening in front of theta. So to pick up all the angles between 0 and 2 pi, you're going to have to write this generalization, plug in numbers to find them all. Remind me again, what was the period for tangent and cotangent? Pi. So the generalization we'll have to use for tangent and cotangent is going to be theta plus or minus pi k. And again, k is an integer. Basically, you're writing a formula. When I say this generalization, you're writing a formula. It is a formula we're going to use to help us generate all of the solutions of this particular equation. We did not need to do this for the other problems because we did not have the number in front of theta. We were able just directly to look at the unit circle and find all the solutions. So again, we need this generalization to find all your answers between 0 and 2 pi. Okay? So let's take a look at how we're going to do these generalizations. So we have the tangent of 2 theta is equal to negative 1. So now, right away, you see that you have a coefficient in front of theta. So to start this problem, what we're going to do is we're going to do that substitution. Let's take out that 2 theta for a moment. And let's just look at this as the tangent of x is equal to negative 1. We should know how to solve the tangent of x is equal to negative 1. So now I'll go back to your unit circle and tell me, first of all, what 2 quadrants is tangent negative? Tangent's negative in what 2 quadrants? 2 and 4. So what's the angle in quadrant 2 that has a tangent value of negative 1? 3 pi over 4. So I know that one angle is going to be at 3 pi over 4. What's the angle down here in quadrant 4 going to be? 7 pi over 4. Should we good so far? Good so far? So now this is where the generalization is going to start. Remember, it's not x. What did I take out? What did I replace 2 theta with? I replaced 2 theta with x. This is where now I am going to make my generalization. So now instead of writing x equals 3 pi over 4, I need to bring back in this 2 theta. So 2 theta is equal to 3 pi over 4 plus or minus, and this is where that generalization comes in. Because it's a tangent, is it going to be plus or minus 2 pi k or plus or minus pi k? For tangent and cotangent, it's a what? Pi k. So any questions on how I wrote my generalization so far? Now you also have another angle to consider. Not only did we have x equals 3 pi over 4, we had x equals what? 7 pi over 4. So I have to do my generalization. 2 theta is equal to 7 pi over 4 plus or minus pi k. So now I want to solve for theta. So how can I isolate theta on both sides of this equation? I can do what? Divide by 2. Dividing by 2 is the same as doing what? Multiplying by a half. So you need to multiply everything in this equation by a half. So theta is going to be equal to, what is 3 pi over 4 times a half? 3 pi over 4 times a half is 3 pi over 8, plus or minus pi k over 2. Especially on standardized tests, remember, in my directions, I'm asking for solutions just between 0 and 2 pi. This is actually your formula to generate all your solutions. Remember, as I mentioned, these trig equations have an infinite number of solutions. This is how you can calculate all solutions. That's it. So if you're taking a PSA, an SAT, and it asks you to find all the solutions, this is what you have to write. Now I'm asking for specific angles between 0 and 2 pi. So the way you start, remember, k represents an integer. You start with 0 and you plug in different numbers for k until you get to angles larger than 2 pi. So we're going to start with k is equal to 0. What happens when I plug 0 in for k here? You get 0. So what's 3 pi over 8 plus or minus 0 going to be? 3 pi over 8. So one solution is going to be when theta is equal to 3 pi over 8. Now plug in when k is equal to 1. So I have 3 pi over 8 plus pi over 2 times 1 is just going to be what? Pi over 2. Now, make your life easier. 3 pi over 8 plus or minus, again, get that common denominator. Don't keep on doing common denominators all over again. Pi over 2 is equivalent to what with a denominator of 8? 4 pi over 8. So when I plug in 1 for k, instead of writing pi over 2, it's actually 4 pi over 8 times 1, or just 4 pi over 8. So what's 4 pi over 8 plus 3 pi over 8? 7 pi over 8. Is 7 pi over 8 still less than 2 pi? Is 7 pi over 8 less than 2 pi? How am I going to know when I get to an angle greater than 2 pi? With a denominator of 8, what's that numerator going to have to be? 16. So I keep going until I get to a fraction that's larger than 16 pi over 8. All right, so right now I've got two solutions. I've got 3 pi over 8. I've got 7 pi over 8. So now let me plug in 2. Again, all I'm doing is I'm plugging these values back into this highlighted general formula. So k is equal to 2. So 3 pi over 8 plus. Now again, remember it's 4 pi over 8 times k. So what is 4 pi over 8 times 2? It's going to be 8 pi over 8. So 3 pi over 8 plus 8 pi over 8 is going to give me what? 11 pi over 8. Now, once I've generated 3, are you noticing a pattern between the 3 solutions that I got? So look, I started with 3 pi over 8. I got a 7 pi over 8. I got an 11 pi over 8. What do you think the next one's going to be without even doing it? 15 pi over 8, exactly. Because notice the numbers, you got to take it out at least 3 to make sure that pattern exists. All right? So the next one's going to be 15 pi over 8, because notice the numerator is just increasing by 4. Is 15 pi over 8 less than 2 pi? Yes. So then right now I've got another solution of 15 pi over 8. Do I need to go another round? What would the next one be? 19 pi over 8. And obviously 19 pi over 8 is greater than 2 pi. Yes, when you see those coefficients, you are going to get quite a few answers. All right? Because you can always check your answers. You can take 3 pi over 8, plug it back into the original equation, and you'll see that this is why, because of that multiple angle, you're going to end up with more than the 2 or 4 solutions. Again, if I just solve tangent of theta is equal to -1 like I did in the beginning, I got 2 solutions. I'm doubling this. Notice I ended up with 4 solutions on this side. Now let's take a look. Remember, you're not done. Because remember, you have that other angle. The 2 theta is equal to 7 pi over 4 plus pi k. So we're going to have to multiply everything by a half again. So theta is going to be equal to 7 pi over 8 plus pi k over 2. Well, if I plug in 0 for k, what is the first solution going to be here? The first solution will be what? 7 pi over 8. Did you already list 7 pi over 8? Yes. Yes. With tangent and cotangent, the nice thing is, this is for tangent and cotangent only. Because the period is pi, one angle will pick up all solutions. In other words, you don't have to go through the process like we just did with both angles. Unfortunately, the other 4 trig functions don't work that way. You'll have to do both. Okay? So you have 4 answers here. So your answer list is going to be, let me just write it out, 3 pi over 8, 7 pi over 8, 11 pi over 8, and 15 pi over 8. So you have 4 solutions for that one. Okay? So those are your 4 solutions. Okay? Let's take a look at number 2. So 4 times the sine of theta plus 3 square root 3 is equal to square root 3. Well, first of all, notice you've got the coefficient in front of theta, which is 3. So let's take out this 3 theta for a minute, and let's just treat it like those equations we've been solving. So we have 4 sine of x plus 3 square root 3 is equal to square root 3. What's going to be your first step? What's your first step to solve this for sine? Because you got to get sine by itself. What's going to be your first step? If this was just a 2, what would you do? Subtract it. So what are we going to do to both sides first? Subtract 3 square root 3. So I have 4 sine x. What's square root of 3 minus 3 square root 3? -2 square root 3. Sine still isn't by itself, so what do we have to do next? Divide by 4. So we end up with sine of x is equal to, when you simplify this fraction, that's going to be negative square root 3 over 2. So now from your unit circle, first of all, where is sine negative? What 2 quadrants are we looking in? We're looking in quadrants what? 3 and 4. So what's the angle down here in quadrant 3? Which one's it going to be? You got your choice of 7 pi over 6. You've got 5 pi over 4. You've got 4 pi over 3. Which one's it going to be? 4 pi over 3. And then over here in quadrant 4, it's going to be your 5 pi over 3. Now, if you notice the pattern, the last one had a 2 theta with 4 solutions. This has a 3 theta with 2 solutions. Take a wild guess how many solutions we should be on the lookout for. If you double 2, what's that going to, if you, not 4, what's 3 times 2? 6. So you should be on the lookout for 6. because it's a 3 theta. You're taking the number of angles and multiplying by 3. So be on the lookout. So prepare yourself. Prepare yourself. All right? So now bring back in that 3 theta. So 3 theta is equal to 4 pi over 3 plus or minus. Now, it's a sine. So what's the generalization for sine? Is it a plus pi k or plus 2 pi k? 2 pi k. How do I get theta by itself here? What am I going to do? I'm going to do what? Divide by 3, or I'm going to multiply by 1/3. So theta is going to be equal to 4 pi over 3 times a third is 4 pi over 9. Plus or minus 2 pi k over 3. Now what I like to do is just go ahead and get this fraction with a common denominator because I know I'm going to be adding fractions together. So I have 4 pi over 9. So let me rewrite 2 pi over 3 with a denominator of 9. So what's 2 pi over 3 going to be equivalent to with a denominator of 9? It's going to be 6 pi. That way at least I know what that common denominator is. So now let me start plugging in these values. So start with k is equal to 1. So when k is equal to 1, or 0, let me always start with 0, I'm sorry. What happens when I plug 0 in for k? It's 4 pi over 9 plus or minus what? 0. So what's my first angle going to be? 4 pi over 9. So this is when k is equal to 0. What's the magical number I'm going to be looking for? How do I know when I get to angles that are greater than 2 pi? Because I'm only generating my list out to angles of 2 pi. 18 pi over 9. 18 pi over 9 is where I can stop. So now let me start with when k is equal to 1. So 4 pi over 9 plus 6 pi over 9 times 1 is just 6 pi over 9. So what is 4 pi over 9 plus 6 pi over 9? 10 pi over 9. So this is when k was equal to 1. Is 10 pi over 9 less than 2 pi? Yes. So now let me do when k is equal to 2. So 4 pi over 9 plus, what is 6 pi over 9 times 2? Well, 6 pi times 2 is what? 12 pi. So 12 pi over 9 plus 4 pi over 9 is going to be 16 pi over 9. So this is when k was equal to 2. What's the pattern? What's the numerator increasing by? 6. So what would the next one have to be? 22 pi over 9. Is 22 pi over 9 greater than 2 pi? Yes. So there's 3 of my solutions. Unfortunately, like I said, only tangent and cotangent can we use just one angle. Remember, there was another angle that we found, and that is your 5 pi over 3. So you have to make a generalization for your 5 pi over 3 angle as well. So I have to set up 3 theta is equal to 5 pi over 3 plus or minus 2 pi k. You guys go ahead and see if you can generate your list. So what's going to be your first step here? You're going to do what? How would you solve for theta here first? What's going to be your first step? Divide by 3 or multiply by a third. Okay? So see if you can generate your angles here.